Hello, sixth graders. We are looking at least common multiple. By the end of this video, hopefully we can find the least common multiple of two or more numbers. Couple vocab words here that we need to know for least common multiple. The main one, because we need to know what that means from least common multiple. This is the product of any number and an integer. So example, the multiples of 10 are 10, 20, 30, 40, 50. So I think of this as like skip counting by 10. The least common multiple then is when we have two or more numbers, the smallest of their common multiples excluding 0. So when we look at 10 and 15 and we think about the multiples of each of them, 10, 20, 30, 40, 50, and then 15, 30, 45, 60, the smallest one that they both have in common is 30. So really important for this lesson here is knowing the difference and remembering the difference between factors and multiples. So when we look at the number 12, when you think about factors, these are all the numbers that multiply together to equal 12. So 1 and 12, 2 and 6, 3 and 4. All of those numbers, when I multiply like 3 times 4 equals 12. Whereas the multiples is taking 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5, and so on. Those are the multiples. So again, like skip counting by 12. So factors for 20, 1 and 20, 2 and 10. These again are all of the numbers that multiply together to equal 20. And then the multiples, that's if we take 20 and multiply it by other numbers. So 20 times 1, 20 times 2 is 40, 20 times 3 is 60, right? So I'm skip counting by 20s, 20, 40, 60, 80, 100. The multiples keep going on and on and on forever. Whereas factors, there's just certain ones that multiply to equal that number. 11, the only numbers that multiply together to make 11 are 1 and 11, whereas the multiples of 11, 22, 33, 44, 55, they keep going forever and ever. Now, when we're trying to find the least common multiple of two numbers, one of the methods that we can do is listing out the multiples. So that means just skip counting by that number. 12, 24, 36, 48, 60. I'm going to pause there. Now I'm going to do the multiples for 9. 9, 18, 27, 9 times 4, 9 times 5, 9 times 6. So now I'm looking. Do I have anything in common yet? Yes, the smallest multiple that shows up in both of them is 36. So that means the LCM of 12 and 9 is 36. So that's one of the methods, listing them out. Not always the best, because if you miss a multiple, you're going to end up with the wrong answer. And sometimes you have to go for a very long time before you find the LCM. So then the next method that we can use is the prime factorization. So that's going back to those factor trees that we had learned about. So first I need to make my factor tree for 16 and 20. So two numbers that multiply together to make 16. I could use 4 and 4. Neither of those are prime, so I'm going to keep splitting them to 2 times 2, which is prime, and then 2 times 2. Those are both prime. Now when I write out the prime factorization for this, I write it in exponential form. So remember, that means with exponents. And since 2 shows up 4 times, we write it as 2 to the power of 4. Now my factor tree for 20, I'm going to do 2 and 10. And then for 10, I'm going to do 2 and 5. And again, I'm going to write that in exponential form. So 2 squared times 5. Now, when we're trying to do least common multiple, we have to take each factor that shows up to the highest power, so biggest exponent, and multiply those together. So when I look at 2's, 2 to the power of 4 is the highest exponent, and then I also have a factor of 5, so I need to use that one as well. So now we're going to calculate 2 to the power of 4 times 5. So when I solve this, I'm going to do 2 to the power of 4, which is 16, And then 16 times 5 is 80. So the least common multiple of those two numbers is 80. The other method for this is what I call the cake method. We use this for greatest common factor. We can also use it for least common multiple. So it says that you need to take out prime numbers. That's not true. You need to take out a number that they both can be divided by. It can be prime. It doesn't have to be. So for 16 and 20, those can both be divided by, they're even, so I know they can be divided by 2. 16 divided by 2 is 8. 20 divided by 2 is 10. You also might have started with 4. Then you look and see, can 8 and 10 be divided by anything? Yes. So I'm going to add another layer. They can both be divided by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. There's nothing that 4 and 5 can both be divided by other than 1, so that's where I stop. Now remember, for greatest common factor, we just multiplied what was on the side. For least common multiple, think least common multiple starts with the letter L. We're going to make an L. So we're going to multiply everything on the side and the bottom. So 2 times 2 is 4. 4 times 4 is 16. 16 times 5 is 80. So the least common multiple for those two numbers is 80. So that's the cake method. Again, not always the best when we have 3 numbers though. So now what we're going to do is we're going to find the least common multiple of 12 and 16, but using each of the 3 methods. And again, you'll get to pick which one you like the best, but I'm going to show with the same 2 numbers, all 3 methods. So the first one, listing the multiples. So the multiples of 12, 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 60. I'm going to stop there and I'm going to now do the multiples for 16, which are 16, 32, 48, 64, 80, and I notice that they both have 48 is the first time that they have a number in common. So that means their LCM is 48. So now let's try that with the prime factorization method. So those factor trees. So starting with 12, my factor tree, I know that 2 times 6 is 12. You could also start with 3 and 4. 6 can be split into 2 and 3. And then again, I'm going to write this in exponential form. So 2 squared times 3. And then do the same thing with 16. I can split it with 2 and 8. 8 can split to 2 and 4. And then 4 splits to 2 and 2. So then for 16, we have 2 to the power of 4. Now again, we're going to pick every prime number that shows up, and whichever one, for like duplicates, like 2, we pick the one with the highest exponent. So between those, we're going to pick 2 to the power of 4, and then we also need to include this 3 on there. We multiply all that together, so 2 to the power of 4, which means 2 times 2 times 2 times 2, and then we're going to multiply that by 3. Well, I know 2 to the power of 4 is 16, and 16 times 3 is 48. And then again, that's what we got on the first method. Last one, the cake method, write them next to each other. A number that they both can be divided by, I know they're both divisible by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Nothing that 4 and 3 are both divisible by other than 1, so we stop there. Take everything on the side and the bottom and multiply them together. 4 times 3 is 12. 12 times 4 is 48. So no matter which method we use, we should end up with the same answer. And again, you'll get to pick which one works the best for you. Make sure to have your notes in class for tomorrow. Rewatch if you're still a little stuck. Come with questions to class.